Okay, calculus question here, differentiation, and we've got first principles, we've got something about tangents, parallel tangents, we've got the idea of a decreasing function, an important one, and finally we've got something about range. We're going to get started with the idea of first principles differentiation, and this is an interesting one because what it does is it asks us to show something we already know the answer to. We know that if we differentiate that function, got a rule to do it, we get that, and from first principles what we've got to do is we've got to fill in the gap. How do we get from there to there without using the rule that we know, and we've got to apply this first principles formula. Okay, let's get started. It asks us to help out to sort this out first. What's x plus h cubed? We could write out the brackets and multiply that. I'm going to do it using the idea of Pascal's triangle and the binomial theorem, and power 0, 1, 2, 3 coefficients when I multiply out will be 1, 3, 3, 1. Powers of x, we'll start with cubed, squared, power 1, power 0, and h will do the same. Cubed, going in the opposite direction, squared, power 1, power 0, and that is my expansion. So that's binomial theorem. A rather quick way, saves me writing out the brackets. You could write out the brackets and find yourself with the same answer. Up to you. But let's get on to the main event. We want to differentiate from first principles here, and that means we've got to look at this first principle formula, which I will deal with first before sorting out the limit. Take your formula, plug in your x plus h and your x to these, and see what we've got. So x plus h in the function. Minus f of x. I'm going to put that in a bracket so that my signs don't get confused. And then I've got to divide it all by h. As is often the way with these questions, a little bit of algebra, I've got to sort this out, get rid of all these brackets. So that's why we were asked this a minute ago. We have got minus 4 of these, minus through this bracket, minus minus 4x, minus the 1, and dividing it all by h. As is often the way with these questions, we have got a lot that cancels. We've got a minus 1, a plus 1, plus 4x, minus x cubed, plus x cubed, and we've got to see what we've got left. Give yourself a bit of room. Divide everything by h. I'll do that now. So dividing all these by h, this one, 3x squared, this one, divide this by h, and divide this by h. And finally, having sorted out this expression, we have the differential is the limit of the expression as h tends to 0. So as h tends to 0, what are we left with? 3x squared for sure. This, as h goes to 0, will disappear, as will this. Minus 4 we're left with. And there we go, what we already knew. The limit as h tends to 0 is 3x squared minus 4, which confirms this result here. So first principles. Plug in the formula, sort it out with a bit of algebra, and then send h to 0, see what's left. It should be what you expected in the first place. And that's done. Let's have a look at the rest of this question. What we have got, diagram helps for this next bit I think. We've got a tangent at P, and that is at the point 1 minus 2. And there's another tangent, I suspect it will be somewhere like that, somewhere else on the curve, which is parallel to the first one, and that's at Q. Question is, what's the coordinate? The gradient on this function, well, the gradient we've just worked out, we know it is 3x squared minus 4. At P, when x is 1, that gradient will be minus 1. And the question is, what other value gives that gradient? You might spot straight away that minus 1 squared is going to give the same answer. Or we could ask ourselves, 3x squared minus 4 minus 1, where does it happen? squared equals 1, and come up with the answer. Plus 1 we already knew, and minus 1, which we might have spotted anyway, so q must be at minus 1. And go back to our function, minus 1 in here, minus 1 cubed, minus 4, y coordinate for q is 4, so there's q. We've got it. Parallel tangents. Next, what have we got? The idea of decrease, an important word in these questions, important to know what it means. It tells you that you are looking for the part of the function where the gradient goes down, the function drops, the gradient decreases. So we are looking for decreasing function, which means that f dashed of x, the gradient, which we know is 3x squared minus 4, downhill gradient is negative value. Where does that happen? X squared less than 4 over 3, so if we square root, 2 over square root of 3, and not forgetting the negative square root as well. If we stay between those two values, x squared is less than 4 over 3, the gradient is negative, the function goes downhill. There's our answer. We might, as an alternative, tidy that up. We could rationalise these two things. We don't need to, there's no great reason to, but we'll do it anyway just to make sure we can. Rationalise means we don't have square roots on the bottom of fractions here. Top and bottom multiplied by root 3. Same here, top and bottom multiplied by root 3. So as an alternative, slightly tidy, more conventional version, we could say that, or indeed that. Means the same thing. Finally, what have we got? The range, another important word for these questions, the range of the gradient. So we're asked for the range of the gradient, which is 3x squared minus 4. The range, good way to think about this, is the lowest point of the graph on this case. Think about the graph. X squared, we know, looks something like this. 3x squared, same thing, but a bit steeper. And if we minus 4, it drops down. Parabola, at the bottom at minus 4. Lowest value, x0, goes down to minus 4. And so the range, what comes out of this function? It's all the values above there. So the range of this thing is that f dashed of x is always given as values greater than or equal to negative 4. We know that if we have a quick glance at the graph. So that is our range of the gradient greater than or equal to negative 4, and that's our calculus question done.